Thank you for coming, everyone. Today is a very special day. It is May the 14th, and tonight there is a lunar eclipse. We have Bill Burnyeat here, the program manager of Canadian Planetariums, to talk to us about what's going on tonight. Take it away, Bill.
Okay, Jody, thanks. Yes, the eclipse actually happened. It's actually Sunday night. We're getting ahead of ourselves, right? It's the 15th, but I'll talk about that more. So the eclipse happens when the moon moves into the shadow of the Earth and becomes invisible because it's no longer in the presence of sunlight. And this happens on Sunday, so the day after tomorrow. So hopefully the weather will be good there at Aurora, so that you can have a look at it. And anyway, we'll explain it. Let's start from the beginning. Before we get onto the eclipse, let's have some sort of notion of exactly what it is that we see when we go outside. And a good model for that is my handy celestial sphere. This ball, this funny looking ball, right, is a model of the sky. When we go outside and look around, we seem to be standing under a dome, and this dome is the dome of the sky. This dome slowly turns around, right, in one day. That's because of the rotation of the Earth underneath it. But the sun, the moon, the planets, stars, and everything seem to be on the surface of a ball. And this ball, as it's rising, it comes up in the east and goes down in the west, right? And the part of it that's tilted to the north is always in sight. So from Canada, the Big Dipper is always going circling around and around and around in one day. Now, if we were to squash that ball, make it into a circle, then we would have a planisphere, of which we have several examples right here. So here we have the sky made into a disk, right? And so all the stars are on this disk, and then disk I load into here. There we go. Okay, so there we go. Okay, so this is a planisphere. It's a very useful thing. You can find yourself a planisphere in various ways. Let's see, what happens is we turn the day of the year to the hour of the evening, right? So we match up the day of the year and the hour. And when they're matched up, then we can see in the window the stars that are visible at night. You hold the star map up, north, south, east, and west being directed to where they are. And then you simply compare the paper with the sky and read off the constellations. You can then, this is a way of learning the constellations. You can find yourself one online at the website of the National Research Council of Canada. And if you look under Star Wheel or Planisphere or some such thing like that, then you can find one yourself and either use it online or print out a copy and make yourself one. Here's an example of a homemade one. Right, so this was made out of a file folder. There's the back on. So the file folder was cut out and stapled, glue and scissors. That's all you need to make one. And this one does pretty good job. Right, so I can take this outside and compare it with the sky. There's even two sides to it. There's the side with lots of stars, and then the side with not many stars. So for the beginners, you start with this one. And then when you get to be good at it, you move up to the other one. Well, so the sky, when you look at it, it has, obviously, there's two different things you can see when you look at a star. One is its brightness compared to others. So some stars are brighter than others, and the colors of stars. Some stars are sort of orange, some are bluish. They have different colors, and the colors tell us something about the state of the temperature of the star, so that the temperature of the star can be read off, and then we can know other things about it, like pressure and volume and things like that. A lot of this work was done sorting out the colors of stars, their motions, and their distances was done just south of you at the David Dunlop Observatory. But as I was telling Jody, that a lot of this story of the astronomy done there hasn't really been told because it's just a teeny tiny bit mathematical. And it seems that as soon as that arises, then everyone runs hiding into the woods. Can't handle it. But my experience is that even things that are quite complicated, can be explained simply and plainly in language that everyone can understand, even children. So there you go. There's my commercial for the observatory at Richmond Hill. Okay, so what we're going to do is see exactly what happens on the eclipse night. So we're imagining it's Sunday night, so not today. Today's Saturday, so Sunday the 15th, tomorrow. We go outside and looking around. What are we going to see? Well, the the first thing we notice is that there's a kind of the sun goes down, but the moon rises up, and the moon will be a full moon tomorrow night. The full moon is needed to have an eclipse. Let's see why. If we grab the Earth here, there's the Earth right there, and here's the moon. The Earth, the moon, and the sun must be in a straight line to have an eclipse. There's two different ways that can happen. One is the Earth can be here, and let's suppose that the sun is over there, right there where the light is. So if the Earth is here and the moon is here, we have an eclipse of the moon. Right? So the shadow of the Earth cuts out the light from the sun, and so the moon experiences darkness. Now, if we reverse this, now we have a solar eclipse. So the moon is in the way of the sun, and from the Earth, we look up and we see the sun is sort of magically disappearing because the moon is in front of it. So that's the eclipse of the sun. And of course, this is the one that we need precautions to take if we're going to observe something like that. I have a bit of an advantage, and the telescope behind over here has a dark filter on it. So if I point the telescope at the sun, hardly any of the light of the sun gets through, so I can safely observe. But you need something like that in order to do it. This lunar eclipse is totally safe because all you're doing is looking at the moon, and it's a bit darker than usual, not brighter, so there's no risk or anything like that. So the moon goes into the shadow of the Earth, and if you're standing on the moon, the Earth would be in the way of the sun, right? And so it doesn't get much light on the moon, but it does get some, because the atmosphere of the Earth projects a kind of a light onto the moon. So that light is strongly reddish, and the red light is scattered in a way such that it sort of projects onto the moon, giving the moon a kind of a reddish color, kind of maybe ochreish or sort of brownish or something like that. Sometimes dark. It depends on many things, and it can't easily be predicted ahead of time. But the moon will definitely look different. So, when does this happen? Well, the eclipse happens on the evening of the 15th. That's Sunday, tomorrow. So the 15th, the eclipse starts at about 10 o'clock. Okay, so the moon will be fairly high up in the sky, and before that, it will look normal. A normal full moon, bright and shiny. You can read a newspaper by its light, and just like you'd see regularly. But as we look, we'll start to see a kind of band of light, darker light, go across the moon in the shape of a curve, and that curve is the boundary of the shadow of the Earth. So by 11:30 at night, the moon will be in its totally in the middle of the eclipse. So between 10 and 11:30, that's the time to observe that this is happening, and it'll be fully done by 11:30. Now, the middle of the eclipse is closer to midnight local time, and then the morning of the 16th, which would be Monday morning, it ends by about 1 o'clock in the morning, and then by 1:30 or 2 o'clock in the morning, if you're still up, the moon will be returned to normal and will look just like a regular ordinary full moon, although there's nothing ordinary about the full moon. It's quite charming at any time. So to recapitulate, 10 o'clock to midnight is the time to go out and observe the eclipse. Okay, so you can stay up later if you want, but it will be ending by about 1 in the morning. So my advice is to, since the moon will rise in between south and east, find a place where you can view the south and the east on a flat horizon. You don't need a place where there are buildings in the way or a parking lot with bright street lights and things like that. Those things are to be avoided. The best thing to do is to find something flat, like a field, right, that's very large and that you can see all the way to the horizon, to the edge of the sky as it comes down, right? So that's the best place to look, because when the moon rises up, you'll want to observe it as much of the sky as you can. You don't need any special equipment. If you wish to bring a pair of binoculars, they make it a little bit easier to see some of the features, but they're by no means mandatory. Okay, so you can just observe the eclipse just with your own eyes and nothing more. Well, some people are really enchanted with the moon and want to take their moon observing a little bit further. And I have an example of that here. We have an eclipse picture. Okay, this eclipse, this is what the moon will perhaps look like. This is a moon eclipse drawing. So that color will be roughly the color of the moon. It won't be the bright normal moon. And I should introduce the artist who did that, who's with me right now. Here is another picture. This one, its theme is not astronomy, but this is a dahlia flower in the garden, and so there's the flower done by our resident artist here at Canadian Planetarium. I'll introduce you, Mr. Bear. Can you come up and show yourself? There's Mr. Bear right there. Yeah. Okay, so you did that drawing, did you? Okay, do you have any other drawings of the moon or things like that to show us? Yes, okay, good. Okay, oh, here's one. This is a drawing made through a small telescope. So you see the trees, and then the moon is right there. And see, the moon has light and dark patches. And if we take a look at the moon, we can see the resemblance of the photograph of the moon to the drawing. I hope that comes across. Now, how is that done? Well, Bear will explain. What he does to make a moon drawing is, first of all, go outside with his binoculars. And now the two discs, the little disc, that's how big the moon would look to your eye, and there's how big it would look in the binoculars. So what he does is, first of all, make a drawing of the boundaries of the dark areas of the moon. Okay, so the moon has light and dark areas. The dark areas make pictures on the moon, for making like a man on the moon and things like that. Okay, so they draw the outline of that, and then after that, he fills in the dark area. Right. And finally, the area that's not dark, the light area, there's actually two different types of the light area. There's really light and then not quite so light. And so those are indicated with little numbers for later work. And then after that, he makes the finished painting or drawing. So in other words, the techniques you'd use to draw anything, like flowers in the garden or trees or things like that, the same techniques are used to draw the moon. The only difference is that if you're drawing a tree, you can walk around the back of the tree and see it, see what's there, but you cannot do that with the moon. It's just not possible. So the moon has a couple of different features we can see. One is over here. This is the dog in the moon. There's the head of the dog, the body, the front legs, back legs, and the tail. So it's a dog made out of the dark areas of the moon. Is that really a dog? I don't think so. No. What happened was, when the moon was very young, it was more or less plastic. And about 3.8 billion years ago, the moon was bombarded by rocks. And so these rocks produce the familiar craters on the moon. If we go up in magnification just a little bit, we can see the round things on the moon are the craters. So these are the impacts left by these rocks. Right? So they've left these stains, but when these impacts happened, it generated a great deal of heat inside the moon. So the moon got hot inside, and then through cracks, presumably, or fissures, some of that material leaked out, right, and left a dark stain. So the stain came after the major portion of the bombardment. And as a result, if you look with a telescope at the dark areas on the moon, they are relatively free of craters. You know, there are some craters there well, from hits of things that happened later in the moon's history, but generally, and certainly statistically, there are fewer craters on the dark areas than the bright highlands. So this can be revealed in a small telescope. And so it's fun to go out and observe the moon, even though the eclipse of the moon Sunday night is a special event, which we're all excited about. There's no need to only observe the moon then. Any moon is worth taking a look at. The eclipses have been observed for a long time, and there were tables producing times of eclipses and things like that, even at the beginning of the modern period. So even going back to the 16th and 15th century, people had some notion of when eclipses would happen. First of all, for the lunar eclipse, the prerequisite is a full moon. So the moon can't be eclipsed when it looks like this, right? Whoop. Because it's a half moon. Right, the half moon has a geometry like this, where, remember, we'll take the Earth. Now there's the moon. The geometry is like this. Right, so the moon and the Earth and the sun being over my shoulder there, are not in a straight line. They make a triangle. So like that or like that, that will work, but not a triangle. And it's where the half moon shows we see a triangle, and this distance was measured even by the early Greeks. What they did was they had a way of mathematically, it was like a mathematical formula, right? And they counted the moons, giving that the moon goes all the way around the sky in about 29.5 days. Right now, there's no such thing as a half a day. That's kind of weird. Even Bear would laugh at that. But what you do is, if you add a 29-day month to a 30-day month, and then a 29, in other words, alternate 29 and 20 and 30-day months, and keep going. After 234 months, that equals exactly, just about exactly 19 calendar years. So there's a lowest common denominator between the two things. So there were formulas and tables that people had even very early in the early modern period and even before, which allowed people to figure out the dates of the eclipses. Another prerequisite for the eclipse is that the moon must be on the path of that the sun takes, which is the ecliptic path. So when the moon is on that path, then there can be an eclipse. But often the moon is above or below it. If that path is here, sometimes the moon is here, sometimes it's here. Right, so where it misses it, then there'll be no eclipse. Only when the moon is near the ecliptic will it endure its eclipse. Right. This is important because if the moon followed exactly the path of the sun, there'd be an eclipse every month, which there certainly is not. So what's happened is that the moon is tilted by about 5 degrees to the ecliptic, and therefore misses having an eclipse about 5 times out of 6. So in a regular year, there are 2 lunar eclipses and 2 solar eclipses, 2 and 2 or 4. The next lunar eclipse will be in November, and that one won't be as important as this one. Although I guess I should give a proviso. I live in Vancouver, so in British Columbia. So where I am, right, there's 3-hour time difference. So when the eclipse starts for you, the moon for me will still be under the horizon. I won't be able to see the beginning of the eclipse, right? And so if we grab, here's the camera here. So there's Canada. Canada is the light colored one. Well, there's Canada. So I'm over here in British Columbia. Well, right over there, and you're over here in Ontario. So the curve of the Earth, right, and the Earth has a curve to it because it's a ball. I don't care what the flat Earth people say. Because of that, while you're watching the eclipse, right, in Aurora, in Vancouver, the moon will not be yet up into the sky. So I'm going to miss the first part of the eclipse. I may see the last part if it's not raining or something like that, but definitely the first part I won't see. Now, the situation in November will be reversed. In other words, I will see the whole eclipse, but from Ontario, the moon will be going down and setting during the juicy part of the eclipse. So when you look out, you'll see the moon will be going down and setting in the west, and you won't be able to see the last part of the eclipse. But in BC, I'll be able to do that. So when I give talks about the eclipses, I have to be very careful because of the local situation. Canada is a big country. We have many time zones, and therefore the moon will appear in different places in different ways, and I have to take that into account. However, there is one thing that I don't have to modify or change, and that is the stars in their constellations. I don't have to worry about that because they look exactly the same here as in Ontario. In fact, if you went to Mars and you were standing on the surface of Mars looking up, you see the Big Dipper, Orion, and the Summer Triangle, and all the familiar constellations would look exactly the same from Mars as from the Earth. And the reason is that you haven't gone very far. Right? From the Earth to Mars is a tiny change in your distance vis-a-vis the distances of the stars. The stars are so far away that they are not modified in their outlines with the change from Earth to Mars. Even if you went to Pluto, you'd still see the same thing. It wouldn't be very different at all. Well, okay, so the eclipse, I'm hoping, will be enjoyed by as many people as possible. I understand the weather is better there than it is here, so hopefully it'll be better for tomorrow night. A little bit about optical aid. Some people saying, I can't do any astronomy because I don't have a telescope. Oh, not so. There's a little telescope here, right? But it's also possible to make a telescope. This is the lens of a binocular, which the binoculars were wrecked. Someone dropped the binoculars on the floor and smashed them. Who might that have been? Who dropped the binoculars on the floor and smashed them? Was that you, Bear? Bear says no, it wasn't him.
It was Bear.
I'm afraid it was Bear. Yeah. Anyway, so they're wrecked. So I unscrewed the objective lens, the lens at the front, and then I also unscrewed the eyepiece at the back. Now, a telescope is simply a tube that has two pieces of glass, one big and one little, right? And the tube holds them so they don't wiggle around. So going to the store, I got this. This is a piece of plastic tubing, right? Which is, you'd use this in the bathroom. Right. So now the objective lens fits in here, and the eyepiece in the other end to make a telescope. Right. So this tube I cut to just the right length. First of all, you have to find out what the focal length of the lens is, and this was 20 centimeters or about 8 inches. Now I determined that by holding the lens pointing it at the sun, and then projecting the sun's image onto a card. Right, which gives you the focus, and then measuring that distance. So once that's known, then you know how long a tube you need to make the telescope. There's other sources of lens. The lens found in an old photocopier, for example, can make a little telescope, or overhead projector or something like that. There's one where I work that I'm looking at quite carefully because it has a nice big lens. I'm wondering if would it make a good little telescope. Often the answer is yes. Even camera lenses can sometimes be pressed into service to make yourself a do-it-yourself a telescope. If you want to pursue that anymore, I think all you have to do is go onto YouTube and then type in at the top, do-it-yourself telescope. And you'll find a variety of situations, a variety of models, Simply take the one that's most comfortable for you, given the equipment and the expertise that you're willing to bring to this project. Right? But I'm sure you'll find something that will be good for you. Or if you're a teacher, maybe something can be done in the classroom, and all the kids can make little telescopes and things like that. That's been done too. Okay, so as I said, don't need a telescope, but it's fun to sort of think about them. Now, I was talking to Bear earlier, and he says, there's more happening in the sky than just the eclipse of the moon, as grand as that is. And so what he did was Bear found some other interesting things that are happening. Bear, do you want to introduce this? Okay, so these are the top 10 astronomical events of 2022. Did you compile these yourself, Bear, without any help? That's right. Good for you. Okay, I'm going to open the card. Now we're well into May, so some of these, the first couple of them have expired, I'm sure, but there's lots of things happening in the balance of the year. Let's see what we've got here. Okay. Okay, so the next thing of interest is, here we go. Bear, do you want to? Okay, I'll read it. Okay, there's a super moon on June 14th. The super moon is much different than the super duper moon, but the super moon is where the moon in its orbit is a little bit closer to the Earth, right? And when it happens to be a full moon. So the super moon looks slightly bigger than the full moon, but you can't really tell unless you have careful measuring equipment. So the super moon may look a little bit brighter, but if you don't notice any difference, I don't either. But that happens on June the 14th. So that is the next full moon after the one that will be Sunday night that will be eclipsed. And as I mentioned, because the moon is tilted to the ecliptic, that will not be an eclipse of the moon. It'll just be a regular moon, although a super moon. So there you go. Okay, the next one is planets alignment, June 24th at dawn. So if you get up and look towards the east at dawn, very low in the sky will be Mercury, the planet Mercury, then the planet Venus, the crescent moon will be there, then Mars, Jupiter, and Saturn. Excuse me. So you have 1, 2, 3, 4, 5 planets and the moon all in the same sort of alignment, right on a line. Why does that happen? I think we can understand if we take a look at the path of the sun, the moon, and the planets. On this yellow line is the path the sun, the moon, and the planets take. So they go along the ecliptic. Now, this is a circle on this disk. So if the planets are scattered here or there, right, they don't appear to be related to each other. However, as they travel around, going around and around, it's possible for them to all gang up and pass each other, just like a bunch of cars on a car racetrack, and they're all passing each other, all sort of clumped together, or horses or bicycles or something where there's a race and they all come to a place where they're all clumped up together. Well, when that happens, if you look closely, this is curved, but if a whole bunch of dots are all together, then the curve, if you only take a tiny bit of it, the curve is like a straight line, right? So this is how we make a tangent in mathematics, because a line that's tangent to a circle, right? If you take only a tiny bit of that circle, it's quite like a straight line, provided the part is very, very tiny. And that's the case here. So an alignment is a tiny part of a circle. The planets are all there, and they appear to us to be all in the same way, in the same straight line. It's just a reminder, though, that the planets only go through the ecliptic and through the zodiac signs. They never wander away from that. So you never see the Big Dipper entertaining a planet. The moon or the planets can't get into the Big Dipper, nor can they visit the constellation Orion, right? They can only visit the zodiac signs, which are sprinkled, 12 in number, all the way around the yellow line. Okay, so that's at dawn on the 24th of June. And let's see, the next the next thing up, there's a bit of a gap. The next one is a Perseid meteor shower. That is August 12th to 13th, 2022. So there is a proviso. The moon is involved in this too, unfortunately. The moon is full when the shooting stars are visible, which is not good because then it drowns out the light from the fainter stars. So ideally, it's best to have the shooting stars going on in the absence of the moon, but that won't be the case. Now, what's the shooting star? Is it a star that's shooting through the sky? No, it is here. This is a rock from space. So what happens is a bit of space, right? A rock from space comes into the Earth's atmosphere, zips through very, very quickly, and as a result becomes luminous and burns up. This piece, though, fell to Earth and was collected by somebody. If you were to, this looks like a rock, but if you were to hold it in your hand, you might be surprised at how heavy it is. It's like iron and nickel, right? So it's quite heavy. It's like a piece of metal, right? The Earth is made out of such stuff. So when the Earth was formed, a lot of iron and nickel fell to the center of the Earth, and that's why the Earth is quite heavy. So if you made a ball the same size as the Earth, but that ball was made out of cement, the cement ball would be much, much lighter than the Earth. So the Earth is quite heavy because it's got all that iron and nickel in it, which it collected at the beginning of the formation of the solar system. The pieces of rock from space can tell astronomers various things, but for us, it's just a matter of enjoying the streak in the sky. Okay, so that's August 12th, 13th. And then there's the next total lunar eclipse, November 8th. Right, November 8th. Now that's the one I mentioned before. This is before dawn, and I put a note here. Western observers see it best. All right, so that's the proviso there. So this is the one for you guys to see. The one in November will be better for Bear and I. That's right. Bear's looking forward to that one. Okay, the next one up is December 8th. So in the winter, Mars opposition. Now, what this means is that Mars goes around the sun like the Earth does, but on the 8th of December and around that, basically all of December, the Mars will be fairly close to us, so it will look very bright. It will look like an orange dot or an orange star, much brighter than the stars, and it will certainly be a charming thing to look at. Mars is sometimes called the red planet, but actually it's more orange or golden color, especially in telescopes or small observing aids. When I look at Mars, I can often see the polar ice caps on Mars, which are little frostinesses that Mars has on the top and the bottom, just like the Earth does. But it's good to remember that Mars is actually not very much like the Earth. Mars is more like a big copy of the moon than a small copy of the Earth. But this wasn't understood a century ago, and so we can still see older books that proclaim that there must be vegetation on Mars and things like that. And of course, the Martians, they ain't there. That's not the case at all. Okay. So Mars opposition, the final event of 2022, comes a little bit later, December 13th to 14th, the Gemini meteors. But wouldn't you know it, the moon is getting in there again, unannounced. So the moon is nearly full. So that, again, the shooting stars will be kind of reduced. But these are the things that are happening in the nighttime sky. So maybe keep those in mind for other observing adventures. But for now, the main thing is Sunday night. Everyone be ready, stay up a little bit later, and see if you can see and enjoy the total eclipse of the moon. Well, I think we've about come to our end. Bear, have you got anything more to add? No, Bear said everything he has to say. Okay. Thank you very much, Bear, for your contribution. Okay, so thanks for coming, and I hope you have good observing on Sunday night and every other night as well. Thanks very much. Okay.
Thank you so much, Bill. That was amazing. Yeah, I think I'm going to have to follow Mr. Bear's example and try to do some moon drawings. I'm feeling inspired now.
I did a couple as well, and your first efforts maybe are not very good, but you get much better as you practice. So by your fourth or fifth drawing, you're actually turning out something that's pretty good.
Excellent. That's fantastic. And yeah, I really liked, what did you call it? A star sphere or a star, the wheel?
A planisphere.
Yeah.
So there are many planispheres. I've got, here's another one. So this is a star wheel, and it operates the same way. You can you can make one at home, or you can buy one that's pre-made and prefabricated.
Yeah, I think the amateur astronomers in my family would really get a kick out of having one of those. So I'm going to check that out.
Yeah. Okay.
Great. Thank you so much. We really appreciate you letting us know all this information, and we're going to be watching the night sky tomorrow night.
Okay, good. Thank you very much. Okay. Okay, Jody. Thanks.
Thanks.
Okay.
Take care. It was great having you.
Take care. Bye-bye.
Bye-bye.
Bye-bye. Okay.